Hello everybody, this is stage 2 video. So in order to be watching this, you have tried all of this front page and now you're trying to see if you're doing this correctly. So draw the reference triangles and find the horizontal distance for the following degrees of rotation. So I know that for 70 degrees, right up to here is 70 degrees. This triangle is so small that I like to pop these triangles out so I can draw them a little bit larger right here because I have bad eyes because I'm old. So we have a right angle right here. We know, I wonder, is this the screamer or not? Oh dear. Well, I'm going to say that it's the screamer, okay? Which means that we are going to have a radius of 100 feet. And the center is right on the ground. So, for this, I'm going to assume that the radius is 100 feet. If you did something different, that's okay. Just make sure that the method is okay. This angle right here is 70 degrees. I am solving for this horizontal position right here. I'm going to label that as x. I know I'm going to use cosine of 70 degrees is equal to x over 100. And people, we're multiplying by 100 on both sides. And so 100 cosine of 70 is equal to x. Let me go to my cellular phone and do 100 cosine of 70, and that got me 34.2. So x is equal to 34.2. That's my horizontal position right here. For this one, 130, I know that this is 90 right here, 90 degrees, 180. 130 is 40 away from 90 and 50 away from 180. So I know it's going to be closer just by a little bit to 90 degrees. I'll mark that 130 degrees right here. Now, I know the first thing I gotta do is make myself a reference triangle here. And we gotta figure out, what is this reference angle going to be? And if 180 is right here, the distance from 130 to 180 is 50 degrees. So now if I know that, then I can pop my triangle out and I can, this wasn't much larger, mark this angle as 50 degrees. And I know I'm trying to solve for my horizontal, but my radius is 100 feet. I know I'm trying to solve for my horizontal right here. So I have an x right here. I know I'm going to say cosine of 50 degrees is equal to x over 100 times by 100 on both sides. And you see 100 cosine of 50 is equal to x. Okay. Let's go, cell phone. 100 cosine of 50 degrees. Now that's 64.27. But let me ask you this. Is this side of the y-axis, does that have positive x values or negative x values? It's got negative x values. So I know that my x value is going to be negative 64.2787. That's going to be that answer right there. For this one, 220 degrees, I know that all the way to here is 180, all the way to here is 270, 220 is 40 degrees past 180. So I know that this is 220 degrees. I'm going to draw myself a reference triangle right here with a right angle. I got to find out what my reference angle is. Let's see. We know this is 180 degrees. The distance from 220 to 180, I think that's just going to be 40. So I'm going to pop this sucker out here. I'm going to pop this triangle out right over here. And I have this, this, and this. My radius is this line right here, 100 feet. And my angle right here is 40 degrees. And I'm trying to solve for my horizontal position. I love this highlighter. And that's going to be what I'm going to label as x right here. Now, I'm going to do the same thing that I've done. I'm going to use cosine to solve for my horizontal. Cosine 40 degrees is equal to x over 100. 100 cosine of 40 degrees is equal to x. Let's get out our calculators, everybody, and let's rock 100 cosine of 40. Haven't I already done this? No, I haven't. 40 degrees. I got 76. Now, here's the question. Over here, is this angle of rotation bringing the rider to a negative x territory or positive x territory? Your answer, my answer, should be a negative x right here. It's going to the left. So 76.60 is our answer. So I got an answer of negative 76.60 is equal to x. Now, people, what you have found right here is that finding the vertical position, what we've been doing for a while now, means using the sine trig function. Finding the horizontal position means using the cosine right here. That's going to be something that will be nice to know. Now, the last thing before I leave you here is going to be, let's try graphing the horizontal distance of a rider on the model of the Screamer. Now, I did mine with 100 feet, and it's okay for you to do 100 feet as well. I'm going to mark this as 100 feet. I'm going to do the radius with the radius. I'm going to do the Screamer with the radius of 100 feet. And my lowest point I know is negative 100 feet right here, okay? Now, my horizontal here is something that's a little bit different. So I want to ask you guys, and I want this to go a little slower. Right here is 0 degrees. Now the horizontal distance right here, that is the same as our radius. That is 100 feet. So actually our cosine function does not start at 0. It starts right up here at 100 feet. That is my first point. Now let's go up to 90 degrees right here. 90 degrees is right here. This is 90 degrees. Now folks, what is the horizontal distance of this point? Is there any left? Is there any right? The answer is nope, there isn't. The 90 degrees is right on the y-axis, therefore the horizontal distance here is 0 feet. So at 90 degrees, I'm going to put a point right where I know 0 feet is, right on the x-axis. Now let's go down to 180 right here. At 180, we're to the left the entire amount, so that's going to be a negative 100. I'm going to go down to negative 100 right here. And at 270, we are back at the y-axis. Guess what, everybody? The same thing. There is no left, there's no right. This has a 0 feet horizontal position. So 270 is right here at 0. And at 360, we're back right up here. 360 degrees. This also has a horizontal position of 100. So this graph looks a little bit different, but maybe you can see how it might be kind of similar to our vertical. Again, it's curved because it's a Ferris wheel. And here we go. And here's the thing, if it kept going, I think you could see that it's going to go down here at 450 degrees, and it's going to keep going on this pattern. I kind of want you to ask yourself, do you see a sine graph in here? That would be something that would be good to think about. Okay? But really, one cycle is just up to 360 degrees right here. Now, what is the maximum horizontal distance of a rider on the Screamer? 100 feet. And you can see that right here and right here, 0 and 360 degrees. What is the minimum horizontal? Well, at 180, it's at negative 100 feet. Negative 100 feet. At what angles is the horizontal distance of a rider on the Screamer equal to 0? At what angles is the horizontal distance equal to 0? So that's going to be at 90, at 270, and at 450 and at 630, but we'll just worry about the 90 and the 270 for right now. 90 degrees and 270 plus the 450 degrees and 630. At what angle of rotation does the maximum happen? Well, the maximum happens at 0 and at 360. 0 degrees and 360 degrees. At what angle of rotation does the minimum happen? Well, that will be right at 180 degrees. Okay, folks, your next job right here is go to the back half and try out this challenge right here, a new Ferris wheel. Thank you very much.